We're on page 27 in the notes. Last time we started talking about the standard normal distribution. I want to just review what we were doing at the end of class last time to make sure that the new stuff we do today makes some sense. A standard normal distribution is just a normal distribution with a mean of 0 and a standard deviation of 1. Standard normal distribution is a normal distribution with a mean, and because we're dealing with a population, we're going to use the Greek letter mu, mean of 0, and a standard deviation, sigma, of 1. If we go and try to fill in the tick marks on our graph below, I've got 0 in the middle for my mean. 1 standard deviation to the right just puts us at 1, and then 2, and then 3. And moving to the left, we have -1, -2, -3. As we talked about last time with the empirical rule, we can still say that 68% of the data is between -1 and 1, 95% of the data between -2 and 2, and so on. But there's a little bit more we can do with this particular standard normal distribution. And in the end, we're going to try to figure out the percent of data between maybe -0.5 and 0.2, and things like that. To figure this out, we need to use the tables that you see in your notes on the next 2 pages, on page 28 and 29. And we already looked at this a little bit last time. The numbers in the table just tell us the percent of data, written as a decimal, that is less than our particular value that we're dealing with. So let me rewrite that one more time. The numbers in the table tell the percent of data as a decimal that is less than our particular value, which we'll just call z. We'll fill in a little more with that later. But looking at the examples on the bottom of the page, we're asked to find the percent of data where all the values are less than 1.15. Well, we're going to go to our standard normal table on the next 2 pages. In particular, I'm going to go to page 29. To read this table, the table tells me all the percent of the population where the values are less than a specific number. In this case, we want to look for the values less than 1.15. I'm going to go to the row for 1.1. I'm going to go over to 0.5. Looks to me like I'm getting a decimal of 0.8749. I'm going to write that one down over here, 0.8749. And then writing that as a percent, we get 87.49%. If we're asked to find the percent of data less than -0.24, well, I'm going to go to my negative table, which is on page 28. And as I think I mentioned last time, you will get a copy of this table for all tests and quizzes involving this stuff. Less than -0.24. So I'm going to go down to my row for -0.2. I'm going to go over to 0.4, and I'm going to see that 0.4052 is the number in the table. Let me write that down, which is telling me that 40.52% of my data has a z-value less than -0.24. I'd like you to take a moment right now and see if you can do letters C and D on your own. In letter C, I want to find the percent of the data where the z-value is less than -2.19. I'm going to go to page 28. I'm going to look for -2.1. I'm going to go over to 0.9, and I'm going to see that the decimal there is 0.0143. And writing this as a percent, we get 1.43%. In letter D, less than 2.17, well, I'm going to go to my positive table, 2.1, and I'm going to go over to 7, which looks like over here, 0.9850, which tells me that 98.50% of the data is less than 2.17. However, sometimes we want to find the percent of data less than a specific value. Sometimes we want to find the percent of data greater than some value. And sometimes we want to find the percent of data in between two values. Well, there are some variations on this that we can use to figure out those calculations. Before we go on, there is one other thing that I do want to make note of under the section that says using the standard normal table. The total area between the curve and the x-axis, if we go out forever to the left and the right, and we were able to actually find that area, the total area will be 1, which should make a little bit of sense. 1 as a percent is 100. 100% of your data is contained below the standard normal distribution. I just want to add in here that the total area between the curve and the x-axis is 1. The total area between the curve and the x-axis is 1. Let's move on to page 30. We want to now find percents of data less than specific values. We already talked about that. Greater than specific values, and then in between specific values. First of all, if I want to find the area to the left of a particular value, let's say my normal distribution looks like this, and my particular z-value is over here, and I want to find the percent of data over here, which will just be the area underneath the curve. All I'm going to do is find that area in my table. Because that's sort of the whole point of that table. That table gives us the area, the percent of the population, that is less than a specific z-value. Well, we're looking for the area less than that specific z-value, so we'll get that straight from the table. If instead we want to find the area to the right of a specific z-value, here's my z-value. Let's say I want to find the area to the right. Keep in mind that the table only gives us areas to the left of specific z-values. I could look at the table and I can find the area to the left of this thing. But I want to get the area to the right. Well, hopefully you remember from what we wrote just a moment ago that the total area underneath the curve is just 1. Therefore, what I can do is I can find the area to the left, this area over here, and subtract that from 1 to get this shaded area to the right. What we're going to do is we're going to use the table to find the area to the left of z, then we're just going to subtract that from 1. We're going to use the formula 1 minus the area to the left of z. The total area is 1, so if I know this area, all I have to do is subtract that from 1 to get my area that I actually care about. But what if instead we want to find the area in between two z-values? Well, let me draw out a normal distribution. And I want to deal with between z1 and z2. I want to find the shaded region between those two. Well, the first thing I'm going to do, because keep in mind, the table just tells us the area to the left of a specific value. I'm just going to find all the area to the left of z2. Find all the area to the left of z2, and I'll just get that value straight from my table. And once I've found that, I will know this entire shaded region, which is a little too much, but at least that's a good place for me to start. But I just want the area between Z1 and Z2, not the area that's to the left of Z1. Well, all that I need to do is find that area to the left of Z1, which I can just get from my table, do some subtraction, and I'll be left with the area in between. The next thing I'm going to do is find the area to the left of Z1. Let me find a color for this one. Let me shade this in over here. And I want to take that green area away from the red area, and I'll be left with the piece that I want in the middle. And we're just going to subtract those answers. So this is the basic idea. Let me show you some examples and see what happens with this. Let's go on to page 31. Looking at page 31, we're told for each of these problems we need to first draw a standard normal curve, and then using our area ideas, along with our standard normal table, we're supposed to find each of the following percents of data. In part A, I want to find the percent of data where the values are less than negative 0.99. Well, I'm going to start by sketching my standard normal curve, which should look something like that. I know my mean is 0, because again, it's the standard normal curve mean of 0, standard deviation of 1. I want to find the percent of data less than negative 0.99. So I'm going to put a tick mark at negative 0.99, and I want to figure out the percent of data in that region. I know before even going to the table this needs to be less than 50%, because if I was looking for less than 0, it would be 50%, exactly half the graph. It should be something less than that. So less than negative 0.99. Go to your standard normal table, taking a look at page 28, and less than negative 0.99 will put us at 0.1611. So I'm going to say that 16.11% of my data is less than negative 0.99. This really isn't anything new. The only extra piece we're doing just to get us ready for the next few problems is sketching a standard normal curve, which I will be looking for you to do in the homework, and then going to the table and picking things out again, because this is going to be very useful when we start doing things to the right and in between values in just a moment. Letter B. Take a moment, see what you can do in letter B on your own. I'm looking for the percent of data less than 2.13. I know it should probably be a pretty big percent because most of the area underneath that normal distribution is shaded. I'm going to go to my standard normal table. I'm going to look for 2.13, 2.1, go over to the column for 0.03, 0.9834. In letter C, I want to find the percent of data where the values are greater than 1.06. I'm going to start by drawing my standard normal distribution. I will mark my mean at 0. And I'm going to put a tick mark at 1.06. Shading in the region, it should look like this. I don't really think this is drawn perfectly to scale, but at least this will be good enough for us to get what we need out of this. I want to find the area of that shaded region. But remember that the areas given in our table are just to the left of 1.06. So what I'm going to do is I'm going to look at the table. I'm going to find the area to the left of 1.06 and then subtract that from 1, the total area. So I'm going to do 1 minus, well, to the left of 1.06, looking at the table, 1.06 is 0.8554. And at this point, you should go to the calculator, type that in. You're going to get 0.1446. Writing this as a percent, 14.46%. The values in the table just tell us the area to the left of a specific value. If we want to find the area to the right of a specific value, we'll do 1 minus the area to the left. Take a moment and see what you can do in letter D. Zero in the middle is our mean. I think this should be a pretty big percent because it looks like most of the region over there is shaded. 1 minus, well, the area to the left of negative 2.16. I'm going to go to my standard normal table. Negative 2.16 is 0.0154. We're going to get 0.9846, 98.46%. 98.46% of the data has a z-value greater than negative 2.16. In letter E, I want to find the percent of the data where the values are in between negative 1.5 and 1.25. So I'm going to sketch a normal distribution over here. The mean is 0. The values are 1.25, negative 1.5. I want to find the area between those. As we said on the previous page, to find the area between two values, we're going to find the area to the left of the furthest right one. We're going to find the area to the left of the furthest left one, and we'll just subtract those. Going to my standard normal table, the area to the left of 1.25, let's see, 1.2 over to 5 gives me 0.8944. Minus the area to the left of negative 1.5, so we need to go to the negative table. Negative 1.50, so 0.0668. Subtract them, and you're going to get 0.8276, or as a percent, 82.76%. You try letter F. Area to the left of negative 1.35 looks like, oops, it's off the screen, looks like 0.0885. Area to the left of negative 2.16, 0.0154. You're going to get 0.0731. You're going to get 7.31%. And that's all we're going to do for today. You're going to spend the rest of the period working on a few problems, just sort of trying some of this stuff out. It's going to be a mix of the less than, greater than, and in-between problems, and Mr. Tyrell will tell you what to do. you will be handing in your work at the end of the period. So make sure you're being productive.